it okay? Okay, I think we can start, right? So, good afternoon. My name is Tobiasz Dworak. I will be talking today about water and measuring of water with the Eclipse IoT stack. So I will try to focus as much as possible on Eclipse projects. As you know, water is quite important for everybody, for humans, not only for our being, but also for our industry and processing of everything. And yeah, today's agenda is introduction, a little bit about process instrumentation, flow meter testbed. So it's our setup at our location where we use it for research development of some embedded devices, but also to get knowledge and test connectivity using Eclipse projects. And not only. Also a little bit about IoT architecture in context of process instrumentation, a little demo, and hopefully, if I will get time, some live coding session, how simple it is to get started with Eclipse Kura. So, as I said, my name is Tobiasz Dworak. I'm software engineer at Global Logic in Wrocław, Poland. Yeah, my position is senior solution architect, but luckily I have a lot of hands-on code, and not only, but also on pipes and water. I started with Java in telecommunication, and for the last 9 years, I'm in embedded software, mostly in C++. Yeah, and I'm the only one liking Java among my team. So, process instrumentation. Process instrumentation is a part of process automation of a process control, which is focused on measuring properties of mediums that are processed by factories or plants or any things. So basically, there are some simple basic properties that can be measured, like level, pressure, temperature, humidity, flow, dimension, color, simple things. And those simple things are input to higher process controls or process automation in order to take decisions or to stabilize some process. There are some devices that are used in process automation, some simple ones like the temperature sensor, which is based on changing of resistance of the metal inside the sensor and giving the output. It needs to be transformed into digital form in order to consume it by control systems or by some monitoring systems. Later we have some pressure sensor. This provides the standard signal 4 to 20 milliamps, so it's a current loop, which in this from 4 to 20 milliamps, it gives you the value of the pressure which this sensor is measuring. Also, this needs to be converted into some kind of digital representation. Advantage of this current loop is that the cables can be relatively long. Then we have flow sensors. Those are more complicated. We are used to see flow sensors in our homes, the simple ones, with a rotor that is turning, and we have the totalizer that counts how much water we spend. Even those flow sensors at homes recently are upgraded with some wireless technologies that can send those measures to the utility company. But in industry, the sensors need to be more robust and more accurate. So on the market, there are several kinds of it, and they can be divided based on the methodology used. So the most common one are electromagnetic. So based on the change of the electromagnetic field during the flow of the medium, water, for example, of other fluid, that the field is changed. So it can be detected and change into the volume flow. Next one is Coriolis one. It is based on the Coriolis physical thing. and based on the different behavior of the water in two pipes and the frequency of the movement of those pipes, we can deduct the mass and the volume of the liquid. And also they are ultrasonic. They are based on the time of the travel of the ultrasonic wave through the water. They are very nice because they can be applied to the pipe without drilling anything or without deassembling the installation. Usually those flow meters provides a standard signal 4 to 20 milliamps. This is like a common one. Process instrumentation tends to be very conservative in sense of standards. So the simple one is quite popular, but also they provide digital standards like HART or Modbus, which are very old but very robust and simple to use. So they are very popular. Those flow meters also can act as a simple control devices. So, for example, we can use embedded applications inside of this flow meter to control batching process. So, filling, for example, bottles of barrels or something like that. And they can be also used in safety installations. So, for example, shut down the plant if the flow reaches some threshold or is below some threshold. The information model of such flow meters usually is based on the registry map. So it's a simple array addressed by a Modbus register number. And in Modbus specification, registers are 16 bits, so they only represent integer values. But the information model it is usually specified in documentation or specification. It gives us information about the data type and how many bytes are used and if it is written right. So if you want to, for example, read the volume flow, we need to read 2 registers. So in total have 32 bytes and then manually convert it to the float. Yeah, it is a flat structure. Grouping of those registers is usually done only in documentation in Modbus. And usually the user or the device or application that is connecting to this flow meter is responsible for mapping those registers into desired parameter or process value with a concrete type. For different protocols like HART, there is an electronic device description file which producers of such devices gives with a device, and there's everything described in the computer understood format and can be integrated into our solutions. But HART specification is not open and they are not open source solutions, so it is hard to use it just for fun. Okay, flow meter testbed. So around a year ago or a year and a half ago, we were faced to test our embedded software. So we created the testbed, but also at the time we think how to integrate industrial equipment with cloud applications or with mobile applications to give some analysis possibilities or some access to that. So we defined some requirements to that. So we wanted to be as close as possible to the real industrial automation or process instrumentation setup. So have real medium, real pipes, and this need to be easy to understood and easy to present on the fair or on the conference or when somebody visits us. And of course it need to be safe and not really expensive. So the issues which we faced is that usually pipes and those equipment is quite large, heavy, need welding or other competencies to assemble such setup. For software engineers, it could be hard to take a welding machine and assemble those pipes. So we choose like a plumbing pipes from the plumbing store that I use at homes. They are with standard dimensions, and they're compatible with industrial piping, so it can be applied with any, for example, flow meter or temperature sensor. And we came up with such a setup. We have a water pump with inverter, so it's a normal pump used at factory sites or at any process instrumentation setups. With inverter, there we can control the power of this pump. Right now we have manual valves. We've got magnetic flow meter, Coriolis one, pressure sensor, and temperature sensor. We use the PLC to have like a facade in front of all those components to have the manual to have ability to manually control this setup. So we have also the local HMI, and everything can be controlled without any other software outside. So without any cloud, any application, or anything, we can control it locally. But at the same time, this PLC is exposing to us the Modbus registers of our TCP, where we can connect our gateway, for example, and expose those data for some analytics or for some control. This is the process and instrumentation diagram, the standard one, which presents what we created. So we have several Modbus lines, for 20 milliamps amps lines, and the temperature standard PT100 line. Okay. So usually IoT architectures are created in context of the cloud and connectivity devices to the cloud and to some enterprise applications. So here we see that one device is connected directly to the cloud. And in process instrumentations, there are devices that have an embedded wireless module that can be configured, and it can send data to the cloud. It is possible, but not usually. This is a nice solution because each such flow meter must be configured and maintained separately. The second thing is that we can have a local gateway and direct connection to the devices. The third one is that the gateway is connected to some kind of network. Like in our case, this is the Modbus network, where our gateway is connected to the PLC using the Modbus network, and we are gathering the data. Of course, there could be also a set of gateways. Each gateway is connected to one device, just to have a facade in front of, for example, flow meter, or in front of the PLC. This is the really nice paper from Eclipse Foundation about architectures, which describes the three stacks that are base for the whole IoT architecture. The embedded thing, the gateway, and for the cloud. And Eclipse Foundation, Eclipse IoT, is providing projects in all of those stacks. This is the rough layers of the gateway stack. So we are basing on the operating system. Usually it is Linux, but it can be also some kind of real-time operating system. We have some application runtime, connectivity layer, which is important here, that we need to have libraries that are providing us the field bus protocols like Modbus, Profibus, or any kind of other. And of course, we need to have some data management, because not always our gateway is connected to the internet or to the cloud. So we need to have some local storage. And the big important here is that we can embed some local application, for example, some analytics stuff or some, I don't want to say safety features, but it could be that this gateway will monitor our setup and, for example, shut down everything if, according to his knowledge, to the knowledge of the gateway, something is happening wrong. We had such accident at our setup that the pipes were disconnected and we couldn't have any knowledge about that. I couldn't have it because I was outside of the office. And our safety installation was designed only to shut down the power in the room. So manually shut down the power, which is normal for such things. But the whole setup, whole PLC program couldn't detect that the water is not flowing through the whole pipes, but it is flowing on the ground, on the floor. So at the time we pour 80 liters of water on the ground, and we haven't got any drain in the floor, so we are forced to take a mops and clean it up. Yeah, so this is our deployment of components in our setup. So we've got on the left-hand side, we've got a PLC, which exposes those registers over Modbus. Then we have an IoT gateway, which is based on Eclipse Kura, and it is running single board computer. In this case, it is running on a Raspberry Pi, but it can be ported to any Linux embedded based device, for example, from Eurotech or from any other vendor. Recently, also, we are thinking to port it for our purposes on Windows HMI panels, but it's a future. And then this cloud is connected to the, this gateway is connected to the cloud using MQTT protocol and native MQTT payload of the Kura. And in this kind of cloud, we have a simple microservice that is listening to the, that is connecting to the MQTT broker and listening for the messages and exposing the measured data of a REST API. Those data then are available on the mobile phone in the Android application. It wasn't a requirement from our marketing that they want to have it on the phone. But there's no really problem to pass it to any other system like Grafana or anything like that. Yeah, so in the setup we are using Kura. In the cloud we are using Mosquitto, and for the future we want to use Kapua. For the demo, I think I will manage to show you the setup with Kapua. So, Eclipse Kura. Do you know Eclipse Kura, or should I explain a little bit about it? Maybe. Okay, so it is a framework for IoT gateways, and it is based on OSGI specification. So it's modular and highly dynamic. It provides API for accessing underlying hardware, for accessing GPIO, serial port, Bluetooth, I2C SPI. It's available for all those small Linux-based computers like Raspberry Pi, BeagleBone, Intel Edison, but it can be ported to any Linux thing. It also manages the network configuration. It provides Modbus and CAN libraries. Recently, it also provides the OPC UA, and it provides standard data services and cloud services. So we are not forced to implement our own layer for sending data to the cloud, but it provides us a really good solution for that. And can be remotely managed by, for example, Kapua cloud solution. This is quite old, I think, but it's show you the layers of Eclipse Kura. I won't really go deep into that. I want to show you something, so hopefully everything will work. So okay, this is the okay. This is the live stream from our office, which will present us the running of our setup. Okay. Yeah, I wanted to show you this on the screen, but somehow something is not really working. Okay. So first of all, this is an Android application which is connected to our network here, the wireless network, and it is talking to the our cloud solution, to the REST API, which is available online. And it shows two green lights. One light is that that it is connected to the REST API, and the second one is that the lamp is showing green. Sorry. From this application, we can control the whole setup. So, for example, we can simulate the error in the pressure sensor. This pressure sensor is connected using the current loop. So, if we break the current loop, there will be an error. So, we have the green light, and this is the error. And what happened now in sense of software? So, this Android application sends the command using the REST API to the cloud, and then the cloud application sends the command to the MQTT broker on a special topic, and this topic was the Kura gateway is listening to this topic and got those commands to turn on the cable break simulation. So in this case, the red lamp turned on. We can turn on the pump remotely. Okay. So we won't see here too much because it's quite static. So everything is. I want to show you the flow meter. Sorry, I think it's demo effect because I cannot see any flow right now when I turn on the pump. Yeah, I see that there is no water. I have a backup there. My colleague is sitting and listening to all the stuff. Yeah, I think right now it will be working. Yeah. Yes, so right now you see here, if you will later came to my phone, I cannot stream it right now here, that the water pump is set to 36 Hertz, so the inverter is set to such value. And at the bottom, we've got the reading from the magnetic flow meter. So we are pulling from the gateway, we are pulling Modbus registers constantly. and then forwarding into the MQTT broker, and from that we can show that. Yeah, of course we have some like features like I can simulate also the green light. I can turn it off just for fun. Oh, okay, I think that's all for this this demo. What I want to show you right now, I've got 5 minutes before questions, right? Okay. So I'm using Eclipse, but I'm not using plugin development environment. I'm using BND tools for developing OSGI bundles for Kura. Here's my setup. I have defined here the workspace where I define where required bundles for my application are lying. In the build BND, I defined the Maven BND repository for Maven Central, and additionally the Eclipse Kura, the Eclipse repository. And from there, I can add artifacts to the local cache of the BND tools, and it will be accessible from the local storage on my computer. This is the topic for a big presentation, I think. And this is the BND project, where in the BND build path, I added the OSGI core annotation and components, and additionally the Kura API and Kura protocol Modbus. This is the one which is delivered with the Eclipse Kura. With that, I can simply write my code, and BND will take care about adding appropriate entries into the manifest file, appropriate imports there, and will generate also the component config files. So this is the simple component, simple flow monitor. So it's an OSGI bundle that have an activator and deactivator. So here is the activate method and deactivate method. Also, I defined some references. So I need a Modbus protocol device service and the cloud service. This is the way it is done using the annotations. And based on those annotations, the appropriate component config for OSGI is created. So in those fields, I will have the cloud service and Modbus service. So at the beginning, I need to create cloud application to have a cloud client. Here I have the name flow metering for ECF. Maybe I will add 1 just to have something different. Then I'm configuring my polling thread. I'm using the fixed rate scheduler here, so I define the runnable here with the method pool PV. PV is like a process value. So this is the method which will be called by this scheduled executor, exactly. So I defined it to be running each 10 minutes. Right now, maybe I will change it to 5 seconds. Yeah. And before I have a method to connect to PLC. So in order to connect to the PLC, in this particular setup, I have to the Raspberry Pi, I have a connected the RS485 converter, and this converter is plugged into the flow meter. So I'm using the serial connection here. So I need to set some properties here. First of all, I try to disconnect to check if I'm not connected. I configure connection, and this method is opening also the port and trying to establish the connection. So after that, I can invoke my my request to the flow meter. So we have this pull process value method, which I'm reading two parameters, water temperature and water volume. What's here below, it's sending those data to the cloud. But first, let's look at the read water flow, for example. So, using this library, provided with Eclipse Kura, we need to prepare the method invocation with such attributes. This is the unit ID, so it's a slave ID on the Modbus line. Usually it is 1, if we have only one device on such network. Then I'm providing the Modbus register, and I'm providing how many registers I want to read. This is the float value, so I need to read two registers, and those will be in this array. If everything went good, I have those values in this array, and I need to perform this conversion. So I need to shift the first register and sum it with the later one. Okay, then if everything went good, where's my method? Yeah, so everything went good. We have two float values, water temperature and water flow. In order to send it to the MQTT broker using the Kura payload, it's a protobuffer zipped payload that is understood only by Kapua, or it can be understood by your application, but you need to provide a way to convert it from this payload to the object form. So we are creating the payload, setting metrics, and publishing it to the raw topic. Right now, I'll try to maybe I will first just show you here. Here's an output, live output from this Raspberry Pi, this Eclipse Kura. And here you see that I've read two values, two holding registers. Then I converted it to the value, which is 28 degrees, which is quite, I think, good. And then I read the volume flow, and here's the value. Here's a mistake that in this log entry is water temperature. And then I published this message to the Kapua instance on such topic. Unfortunately, I cannot log into that Kapua instance, so sorry for that. Now, I think it's a demo effect, and yeah. Also, my Chrome browser is not working here. Do you have any questions? That's all from me. Yeah.
I have a question. So I recognize that you're using PhD tools.
Yeah.
For developing.
Yeah.
So do you actually have like a strategy for running the emulator with the tools?
I think it will be possible, but I never go that way. I just simply it's a simple way to develop OSJ bundles for me. But runtime, it's a way to go, I think. Yeah, I cannot really log in there. Any other questions? So please evaluate my session. Oh, yeah.
I think the package name was hinted. Is the code for this available on GitHub or somewhere?
It's not available yet, but I think this simple example, I can put it on the GitHub. This is the thing which I prepared for this conference, the code I show you. The one which is using the mobile application, this is our in-house development using the older Kura version, so I don't want to put it on the internet. Yeah, but this one, yeah, of course. Yeah, I'm really disappointed that I couldn't show you the Kapua thing. Okay, so thank you. Please evaluate my session and give me feedback.